Welcome to this, the fifth installment of the beginner series into game development in Unreal Engine 4. Today we will be looking into blueprint communication. We already have scratched a little bit on the surface in the previous tutorial because we had a volume in a class which was communicating to the player, a different class. But today we will be broadening our ways of how we can communicate and going into more details around what is needed. First off, let's cover some of the basics of what is needed when you're performing blueprint communication. There is no open broadcasting way of like sending a message to everything and anything that wants to have a message. You need to have direct communication, and you need to do this by having a sender and a receiver of information. One or the other or both needs to be able to establish a connection with each other, and they do this by finding a reference to the other object. Once they have that reference, then they can send their information in a few different ways. So let's get started with some examples, and then it will hopefully become much clearer about what we mean about these different things. Today we will be using version 4.26 of Unreal, and we'll be using a first-person character template. As you can see, we're in the same project as we ended last time, so if you want to continue and build upon that project, that works perfectly fine and will save you some time. And also you'll have some of the objects available to you already to build on further. So, the very first thing we're gonna do, that we're gonna be altering and building upon in this tutorial, is we first go and find our first person character. So we can find it out here in the world outliner. Scroll down until we find it here, and then we'll click on the link which will get us to the blueprints. Now while we're here, what we want to do is we want to set up some sort of way for us to interact with the world. And we'll make it easy for us today. We should probably do an input, but to keep it slightly shorter, we'll just do a right click and type keyboard and E, which is usually the key that is used for games when you want to interact with an object. So we'll just click on E here, which means that we create a node which will fire whenever the player presses the E key on the keyboard. From here, we're gonna compile and save, and then we're gonna create our first class by going back into the folder structure. The first class we're going to make is a very simple class. We will right click and then create a blueprint class of the parent class actor. We'll call this one BP box. We open it up, we dock it, and for visibility's sake we're gonna add a component, and we're gonna type in box. No, we're gonna type in static mesh, and we're gonna call that static mesh for box mesh. And on the right hand side here under static mesh, we will choose a box, not the skybox. Let's choose a static mesh cube. So type in cube, or you can see 1M cube here. So now we will have a representation in the world which will allow us to see which object it is. So our class is just called box so that we can see that it is a box, and that will make it easier for us to identify what's happening. So now we'll go under the event graph. Under the event graph we can delete everything except begin play, and we will make a custom event. So we will right click and type in custom events. We'll call this event interact. Yeah, that should be fine. Okay. So this event here will represent what will happen once this object is interacted with. So for our purposes we'll just put in a print here to represent something happening, and then we can build upon it further later. So we'll drag out a connection from interact, type print string. We'll say in the print string that box has been interacted with exclamation mark. And then we'll compile and save. So now if we go back to the map and we were to drag this box out into the world, like so, and we were to start playing, nothing would happen. No message is being displayed in the top left or anything like that, because we have the means of communicating with this box now, but we're not actually doing it. So let's set that up. So the first way, if we go to the first person character, we go to our node that represents we are interacting with something. The first way of finding this object to interact with that we're gonna be touching today is one that you should probably almost never use, or under very controlled circumstances, and that is the find actor by class node. So if we right click, type find, my bad, actor by actor class, what is it called? Get actors, get all actors of class. This is the node we want. Okay, so this node, what it does is it will go through your objects in your world. It will match all of those that are of the type that you want. So for us, we want in this example to find the box class, BP box, and it will return an array of those values. So an array is a collection of items. In this case, there's a collection of references to each box in the world. So it stores them in an index-based way, meaning that the first result it brings back has index 0, because that is how programming languages usually handle arrays. And the second index, if there are two results, will have the index 1. So you'll have index 0 and index 1, and you can get either of those references and then start manipulating them. So let us do exactly that. So we'll drag out the connection from out actors, which is an array, and we want to get a specific one, so we can type get, which will get a specific copy of the array that we have gotten back here. And since we talked about 0 being the first index that is available in the array, we'll try to get that one. And then from that one we will have now a box reference, and we have an interact event that we just created earlier, which we'll then be calling. So what we're doing is we're getting all actors of box in the world. We try to get the first one, the one with index 0, and then we try to interact with it. There is one problem with this, however. In case we do not have a result sent back, there are no boxes in the world, then we'll get back an array that's empty, and then we try to get the first result in this array, and that doesn't end very good. So what we need to do is we need to make sure that the result that we get back is actually valid. And we do that by dragging off this node over here, typing is valid. We'll take the one with the question mark on it. Looks like this. And this is basically the same as an if statement happening. So what we're saying is we want to execute here with this object reference, and if it is valid then we'll continue. If it is not valid, we don't bother doing anything else in this particular instance. An if statement is a form of game logic to direct your game flow in certain ways depending on certain things. It's called an if statement usually in programming languages. In Unreal it's called a branch. If you right click and type in if, you'll get a branch as an example, or as a suggestion. You can also get a branch into the world by typing branch or by holding down the B key and left clicking. And this works in a very similar way to above up here. You see you have an execution node, you have some kind of condition you're checking against, and if it's true you'll continue from this node, and if it is false you can continue from this one. So now that we have our reference to our object and we try to use the interact function on it when we press the E key, let's see if this works. Compile, save, go back to the map, start playing, and then we press E. And you see the text appears in the top left of the corner each time we do it. Box has been interacted with. Okay. Now I'm gonna explain to you why this is bad. Get actors of class is a very simple way to get a very specific actor that you want to have somewhere in the world. You don't need to like have any relation with it other than knowing what the class is. So that's very convenient, which is why I'm showing you this. However, depending on how many objects you have in the world of this class and also of other objects, that means that the actual execution of trying to find these objects can be very heavy. So since it is convenient and it is sort of heavy, some people can tend to use and lean against this ability way more often than they should. This is something that you should be doing rarely. So for example, if we had our begin play event. Okay, it's already created here. This is the event that creates when this first person character is created in the world. If at this point, for example, you wanted to find all the boxes in the world to make sure that you save one of them down, or maybe even all of them, you could have that code here so that it only executes once and then it keeps track of everything that it wants to have. So when, let's see if I can find my way back to our node here. So if we were to do that at the begin play, then we could, for example, here each time we press E, go and find a reference to a specific object or the whole array possibly, and then just use it here. So if we were to have, let's say, let's type in a temporary custom event test, and it were to have get actors by class, like so, and it would have BP box. Then we could right click on the out actor here, say promote to variable, and we get a variable of the type object of box in array. This squared 3x3 Rubik's cube here represents an array. So we'll rename this one boxes. So if this was the begin play event, then we could get all the actors of the class and we will save them for later. So then when we run the interact event down here, we could just be using a reference to our boxes and say get and copy of 0, and it would basically look like we need to have this node, so I have something to drag into as well, like so instead. So we would just use the array that we already have, we'd get an index of it, we would check if it was valid, and then we would try and interact with it like so. Since we have now currently not saved it in this particular way, we can't use it in this particular way, but this is good for you to know so that you don't lean on this too heavily, but you have it as a tool in your toolbox that you can use if you need it, but you're aware of the pros and cons of using it. Now let's discuss a different form of communicating to actors, and that is by using line trace. Line trace is if you imagine having a laser pointer device. when you click it on, you immediately see a red dot on the wall or whatever you're pointing it at. That is pretty much exactly what a line trace is in Unreal Engine. What you do is you choose a starting location and an end location in the world, and then you say activate a line trace between these two different points, and then it sends this laser beam out, and any objects that it encounters and passes through on the way, you can then get information about. For example, like we're doing now, we can get an object back if we hit an object, and we can use that reference that we get from that line trace to communicate with. We'll demonstrate an example of that now. So we'll start off with, we're going to reuse our E key here for now. We're just going to disconnect it from our previous code about like getting the information through an actor in the world. And we're instead going to get right click and type line trace by channel will work for us. So this will be the meat of what we're trying to do. But we first need to determine our location to start from. What we can do is we can get our capsule component, which represents the capsule that is surrounding our character, which for most cases is used for collision of like preventing to move through objects and similar things. So this will get the center point of the capsule component, and that will be our starting location for our trace. Let's see here, get location. So we'll get the world location and we'll plug that into start. We will use the pressed node in there to form a connection. When it comes to the end, we need to do something else. We need to find a location to actually have as an endpoint to make this start and end form an actual line in the world. So what we can do is we can drag off the capsule component and we can get forward vector. This means we will get the direction of whichever way the capsule component is currently facing. From there, what we can do is we can say that we want to reach a certain distance in that direction. We do that by multiplying. So we type in multiply and we can take vector versus float. Now this might seem a little bit odd, so I'll try to explain. A position in the world can be both a location and a direction. So a location in the world that is x equals 1 and y equals 0 and z equals 0 means that you're going in the x direction, or you're one unit in the x direction, 0 units in y and z. So that's your location in the world. But the exact same thing can be applied to describe where you're facing or which direction you're aiming towards. So if we had the exact same parameters or coordinates, we had x as 1 and y and z as 0, that means we, from the center point of a three-dimensional grid, would be looking towards our x equals 1. So that means that our direction is 100% in the x direction, 0 in the y direction, 0 in the z direction. So what happens is we get one such direction from our forward vector here, and we want to multiply it, meaning we will scale it up. So if we were to scale this by, let's say, 300, this is Unreal units in this case, and a unit in Unreal is a centimeter. So 300 would mean that we want to scale it 300 times or 3 meters. Meaning if we had an x of 1, the x will now be 300, meaning 3 meters along the x-axis. Since the y-axis was 0, it will be 0 times 300, meaning we will have 0 centimeters or meters in the y direction, and equally the same for z, meaning it will go directly in the x direction, checking 3 meters, and if we were to use that as our endpoint here, then it would mean that that's where we would be scanning towards. However, as we said, this is calculated from where the center of the grid of 3D space is, which is 0, 0, 0. That isn't very helpful for us. What we want to do is we want to add this direction with the position that we have. So we'll take a vector plus vector. We'll add them together like so. This means that we now have said we want a specific direction from a specific position. So that will pull us from the start point of being where we are to the end point of going 3 meters in the direction that we're currently facing as our end point. And in between those 2 points is where a line will be drawn, and our result out hit here will be presented to us. Before we continue, we should probably do some good practice, and that is to prevent this from being hard-coded like so in the code somewhere where it's possibly difficult to find, and we'll instead right-click on this 300 and promote it to a variable. We'll call it trace distance. So then compile and save, and you'll see the default value is whatever we put in before, and you can change this to something else. So if you wanted it to trace further or shorter, you could just tweak this value and it would reflect here, and it would affect the trace by channel here. So let's actually work with our result from here now. So what we get from this line trace by channel is we get an execution node, we get a blue out hit, and we get a return value that's red, which means it's a boolean. This blue out hit here is a structure. You can see it when you hover over. It says hit result structure. And a hit result structure, or a structure in general, is a collection of variables. Not like an array which has the same type of variable in it in different indexes. This is well, we'll just demonstrate it. If we right click on this, you can take split struct pin, which is similar to when we divided up a coordinate to have our x, y, and z value in the previous tutorial. And this will show us all the different variables that this struct contained. You can see which variables were added because it was originally called, if we right click again and recombine struct pin, it was called out hit. And then if we split it again, you'll see it's called out hit blocking hit, for example, as the first one. The prefix here, out hit, is just coming from the structure saying that I was in the structure out hit, and the variable blocking hit is here, and it is of the type boolean. And you see that we have a bunch of different variables available to us from this struct. So what we want to do is that if we found a box out in the world that we want to interact with, we want to interact with it now that we have this line trace available. And we do that by getting the out hit actor here. We'll drag that out. Now this will be of the type actor, and actor doesn't have our function that we created that's called interact. So for us to be able to use that function, or rather that event that we created called interact, we need to first cast this to the right type so that it knows that it has that event available to it. So we'll cast this to BP box, and if the cast was successful, then we want to use the interact event. There. Compile, save. So let us go back and test this functionality out now. Go back to the map and we hit play. And now if I press E, nothing happens because we don't have the direct connection that we had before to the box. Now we need to actually have the line trace hit. So let's instead point towards the box and press E. And you can see that still nothing is happening here. I'm pressing the key and nothing is happening. The reason for that is we said we would scale this line trace 3 meters or 300 times against the original direction. And we are not currently within 3 meters of this object, so that is why we don't get the print. So if we move a bit closer and press E, still nothing happening. But now you can see interacting with. So now I am within 3 meters of this object and the line trace is hitting the object, which is calling the interact function or event on the class. Now this works for a box, but what happens if we have a different object that we want to interact with? So let's create one and see. We'll right click, create a blueprint class, and let's say that this class is very different. Now they might not look different in this example because we're keeping it rather simple, but the box class could be something like a lamp that you go and interact with, while this other actor or other blueprints that we're creating now could be possibly a garage door. And you can interact with both of these things, but they behave very differently. A lamp would switch on or off, and a garage door would open or close, for example. So let's finish creating this and it will become much more clear where I'm going with this. So we'll call this one BP Sphere. And we'll open that one up. Add a component, static mesh, and we'll call this sphere mesh. Didn't quite, there we go. And let's see if we can find a shape sphere in our search here. So this is what we get now. This will be fine for now. So we'll compile and save. And what we do is we go back to our BP box. No, we don't. We go into our event graph, let's do that, of the sphere now. And we'll make a custom event here as well. And we'll call this one interact as well. And we'll say type print, and we'll say circle blueprint interacted with exclamation mark. Okay, just to make this clear, we're gonna expand the print string and change the duration to, let's say, 6 seconds. And we'll make the color, what's a good color? Let's make it dark blue. And then we'll compile and save, and we'll go back to the box and we'll expand its print string and we'll make the color green. And we'll change the duration to 6 seconds there as well. Compile, save. Let's go back to our map again. Now, if we were to put this object into the world, like so, we now have our box class and we have our sphere class. And we have our line trace which goes and tries to find an object to use with and then interact with it. So let's see what happens when we try to play with this. So we'll go up to the box, we'll press the interact key, it says box has been interacted with. Then we'll go to the sphere, we'll do the same thing, and nothing happens. Why is that? Well, if we go back to our first person character and check our interaction logic, you can see that we press E, we try to trace, we get an object, and we try to cast it to box. But this is not a box, this is a sphere. So we need to make some considerations for this sphere to communicate with it. So what will we do? If we cast to something and it fails, it's basically saying I am not of this type. That doesn't mean it will crash or anything like that. It just fails in saying, I am not a box. But if we have a sphere in this case, it will fail. What do we do? We can go from the cast failed, and we can try and cast again. So let's go and cast sphere. Let's see, did I BP sphere? There we go, BP sphere. We'll take the same object reference and say, okay, cast the BP sphere. And if it is a sphere, it also has an interact event that it can use. And we'll try and connect that one here. We'll compile, save, go back to the map, play, go up to the box, interact, it says it has been interacted with, go up to the sphere, and we now see in blue, circle blueprint has been interacted with. Very good. That will be the end of part 1. I hope you'll join me for part 2, where we continue to explore how to communicate between blueprints and see what else we can learn.